Good evening, everybody, and thank you for joining us for tonight's vBrownBag. I'm your host, Tom Green, and tonight we're going to be talking Terraform GitHub management. Our presenter will be Greg Swift. Before we get started, a little bit of housekeeping. I want to get you in on the conversation. So I'll be monitoring the @vBrownBag Twitter and hashtag vBrownBag. So if you have any questions for Greg or any other tidbits to chime in with, please use that. While we are the US channel, there are many other channels across the world. If you go to vbrownbag.com/brownbags, you will be able to check out our schedule, see who's coming up, and sign up for the email reminders. Tonight's episode is going to be a little different. I'll be running the slide deck and taking Twitter, so please bear with us through some technical issues. And with that, I'd like to hand the conversation over to Greg. Greg, could you introduce yourself and pronounce your Twitter handle? Because I don't know if I could.
So my name is Greg Swift. I'm been at Rackspace for a while. I do systems engineering and architecture stuff, mainly on internal systems, running internal platforms. Been doing similar stuff for the last 20 years. On Twitter, I'm Zaeth, Xaeth.
All right, yeah. Cool. Thanks for that introduction. And let's go to. All right. You should be. It's not vBrownBag without technical difficulty. There we go. All right. So if you can see, you're ready to go.
Yep. All right. So this talk, as he said, is Terraform user management, or Terraform GitHub management. What that means is using the tool Terraform to manage your GitHub configuration. The tools that we would typically use for this are, GitHub itself. You can do this with public or private. Terraform, which is, I have a really good explanation on it later. S3 for shared storage of Terraform state, and then you'll need a CI/CD tool. Those are just kind of some prerequisites. You could totally use Travis. There's other shared storage. I'm just going to mention S3 when we get there. So this was originally going to have a kind of walkthrough demo. I'm actually going to post the majority of how I did the Terraform, and you can go look at the Git log in the in the repository to see basically each of these steps represents a commit inside the Git log. And I'll go update the messages to specifically say the steps for clarification. We currently use this primarily for our internal GitHub management, but you can totally do it with public GitHub as well. The thing that Terraform won't handle for you, which is why it's step one, is go create an org in GitHub. There's just permission related issues, and then the API, I believe, doesn't actually support creating a new org. But that's what I remember from one of the pull requests. So Terraform itself is a great tool. It's analogous to Ansible in some ways, but different in others. It's a stateful not component, but a management of stateful resources via API. So any API that you interact with, you could configure it to where Terraform can statefully manage those things. It's actually something I find very interesting about Terraform, because while tools like Ansible can do these things, and then they can do them fairly well, it just seemed like there's a lot of SaaSes that are like, yeah, we're cool and we give you an API, but why would you want to config manage your API? Like, why would you care about the state of those things, or reproducing something? Like, if you've got to create 20 instances that all have to have the same config, just go write a script and That just always seemed kind of off to me. So the fact that Terraform is actually readily doing this for a couple of things like GitHub and PagerDuty is actually pretty cool, because those are two that I've historically had to deal with that don't have that. So when you're using Terraform, basically you have a Go library that you use, or sorry, Go binary that you use in the CLI. It has a couple of CLI options, and then it's running against Terraform files. Terraform files contain HashiCorp config language. It's another config language. It's got its limitations. It's not a programming language. That's important, kind of like in the old days of Puppet before they added loops and everything, like very much declarative type language. So there's some interesting things that you have to deal with when you run through Terraform. Loops being the number one thing. We had to discover some very interesting cleanups around that. That's one stateful, or one issue with the state and the very closeness to the names. I'll talk about that in a little bit. Okay, so the main commands that you would use, and I'm sorry if you hear the cat, they have a mind of their own. Terraform init.
Pets are very welcome on all vBrownBag podcasts. So.
So when we first started using Terraform, we actually ended up in a situation like 3 months after we started where we thought we had set up shared storage of our Terraform state. The state is what maintains what Terraform expects to see so that it can compare that to the API. And so if you don't have that state, Terraform might just go blow everything away. We thought we had it set up properly, and it turned out that it wasn't, and we had to rebuild our Terraform state from scratch. And so now we've actually got it set up. So Terraform init runs pretty much every time we run Terraform, just to verify. Terraform init, one of the things it also does is it loads modules and providers from Terraform. Providers are things like GitHub, VCD for vCloud, PagerDuty, anything like that. They've got it modularized. So Terraform init will load Terraform Git every time it runs, so that helps ensure that you have everything ready locally before you move on. So we weren't doing a Terraform init, and so that's why our stateful set wasn't set up. So it's really important to just make sure you're running that. If you're building out automation, it's a good thing to just include in there. It's a low cost and helps make sure you're moving forward correctly. Git is handy if you just start playing with modules and doing development. So you don't necessarily have to run the init, but at the end of the day, I just run init most of the time. And so plan is the next main thing you would use in your workflow. And basically, it takes your local state and goes and looks at the API and does a comparison and then just tells you, this is what I'm going to do. You can save that plan to a local state file to ensure that it only repeats that exact same thing in case something changes in between now and the time you hit apply. But it's a non-destructive, just tell me what's going to happen. So then Terraform apply is the potentially destructive one. That's what creates things, that's what destroys things. Anything that the plan told you it needed to do, it will now do. And then Terraform state allows you to view and interact with that state. There are times where you might need to import a state from something that already exists because you're just now implementing Terraform and you want to cover old things, or you may want to renumber something or change the name of it, and so you have to adjust the state. So that's really useful for those things. So this is the point where in the demo we would be basically just creating two simple files, because this is GitHub. The way I would start is I would create GitHub file where I would just define the Terraform provider for GitHub. And that only really requires the version of the provider, a access token, and a URL for the GitHub. So whether it's public GitHub or your internal GitHub. One of the things that we didn't do originally, because we just used lowercase letters for all the variables, I would recommend doing uppercase letters for these variables, especially for like the GitHub token. So that way, when you're saying them in your command line, it just looks a little bit more like the environment variables that you're used to. Because any variable that is defined as a variable that can be overridden, you can override using an environment file or an environment variable. So we would set the GitHub.tf up, and then we would set up one called variables.tf. And the variables.tf, you would define them with those names, and you could give them a default, or you could just set it as blank, and you can potentially give it a description, which provides some additional documentation for your users. And at that point, if we go run Terraform plan, it's going to, we're going to run Terraform plan, and it's going to be like, okay, there's nothing to do here. We know that Terraform or GitHub's there, and that's about it. So then the next step would be to go add some members to our GitHub account. In some ways, the separation here can end up looking a little convoluted, but effectively you have your GitHub membership, and that just means that I'm inside this org. It doesn't put me on a team. It doesn't give me permissions to any repositories. It just defines that I'm part of the org and whether or not I am a admin or a regular member of the org. So then you have to, when you define a team, you would define the team itself, and then you would define yourself or your users as a member of that team. So here I'm saying now that you would define each user twice. Terraform does support some modularization, and so we can collapse some of these down later, but as you get started, this is basically where you do the separation. As we started off, I would lean towards the separation of taking these concepts and making them separate files. So I would do a members.tf and just do the GitHub membership in there for the users. And then for the teams, I would do a file per team, because each team requires a GitHub team definition and then a GitHub team membership definition. And so rather than, if you're a reasonable size org, you could end up with 5 teams to 50 teams and, dozens of users in some of them. In a single file, that's just hard to track. So I would just normally do something like team_teamname.tf and go put the unique things there. This is very much just kind of setting up a usable structure from the get-go, with the intent that once we know everything about what we're doing, we can potentially abstract this and even clean it down to a quarter of the size. So we've got the org, we've got members, and we've got teams. So now we need to define a repository. What do I'm in this org, but what's the whole point of GitHub? Have repositories. So we'll add another file. This will be like repo _ and I believe I called it Terraform-GitHub-As-Code because it's Terraform managing and then the repository name that I wanted it to be. So kind of cyclical. The demo is actually creating the repo that has the code for managing the org that the repo's in. So inside a repo, you have, let me actually pull it up. You have the GitHub repository, which is just the name, and in this case, it's GitHub-As-Code. I did drop the Terraform off the beginning. And then I do private equals false because I want it to be a public repository. And then I do an auto init true. And the reason why I do most of the things that I said in here are just so that they collectively work together. We auto init true because one of the things that I wanted to get out of using GitHub was that enforcement of settings across multiple repositories to be the same. The biggest reason of which was so that we could enable branch protection and require reviews. For me, that's the key, is I want to be able to enforce that all my repositories are configured exactly the same. I want the same webhooks as appropriate. I want branch protection and checks as appropriate. So we auto init to make sure that there's a master branch. Otherwise, if you create a GitHub repo and you don't have GitHub auto init it, you just have an empty thing. So we define a GitHub repository, which is very minimal. Then we're going to go in and we're going to define a GitHub branch protection. And we're going to set that against master. And basically, what you'll see is me requiring enforcement of the branch against admins, requiring that all status checks for pull requests are passed before it can be merged. And then if somebody pushes to something that's been reviewed, the review should be made stale. And then we can set a dependency, because if Terraform does this out of order and tries to create the branch protection before the repository, it's gone, or it will error, it's not gone. So we just set a simple dependency backup on the repository. So that's the meats of the settings there. One of the things I'd love to add is labels. I've never ended up using labels in most of our repositories, and we tend to do repository sprawl in my groups just because it was so manual to go add work in progress and all the other labels to GitHub. So that all just does the basic setup. We then define a team for the repository, and I went with like an admin team. So this is a team that has full admin control of the repository, and then a community repository, which is the one that would have push. There you can add a third group or a third permission type, which is pool, which is helpful if you have private repositories. So like I said, a lot of that sounds like, okay, I'm defining all these things, but it doesn't sound like I'm getting the enforcement and the consistency between the things, but I have a lot of repetition. So each repo ends up being a 46-line file in my current version. And then right now my team is about 12. So that's, and then members is 9. So close to that 64 that's in here. So, and I'm going to go publish this as well as part of this, that they're not, I don't know how consumable they are. They should be generally consumable, but I'm going to go publish our modules. We have one for GitHub team and then one for GitHub repository. And so that allows us to basically have those things variabilized and set. And so then you can just, rather than having a file per repo and a file per team, you can just have a team and a repo file, and each one just has a short definition block per. And so then you can also, oh, well, we want to add labels. Now I just go update the module to support labels, and and then go update the default value that I'm passing in, and now everything gets labels the next time I apply Terraform. So since we created the module, Terraform or HashiCorp has actually put out a registry for people to register modules. I went and looked, and there is not any for GitHub yet. And so I'm looking at moving our GitHub modules into it. And so I feel like I missed a slide here, and I apologize for that. So what led to this becoming vBrownBag was I was cracking on Twitter about the fact that I was having to, I don't remember exactly what the crack was, but it was something about the management of the state. We use the count in the module, so there's no easy way to pass in and just do a loop with Terraform. And so we pass an array, and then inside the module, it looks at the count through the array to associate the people or the teams to the repositories. We had a user quit, and I had to shuffle the state files over. And that's basically what caused that little rant. And So the caveat here is that I went and deleted a user just out of the file. That user's ID index was 0. And so when I ran Terraform, it basically deleted every user, but recreated it. And so that actually broke some things, because it deleted me as one of the first users, and so then I lost access to finish the work. But this is where managing the state file comes into play. The primary way of working with it is to use the Terraform state move command. You can use view and list to kind of explore it. In a worst case scenario, you can grab the state file and munge it, do the shifting yourself. I would personally encourage getting comfortable with the command line instead, but the time when we thought we were doing the shared state file and we weren't, we had to basically create our entire state from scratch so that we didn't destroy anything. And then I also listed here how the import command works. So that's really useful, like if somebody ignored your process and went and grabbed all of the, or went and created a repository and started doing some work, and you came back and you're like, hey, where did this come from? Well, because it's there and your config doesn't know about it and the state doesn't know about it, Terraform doesn't know about it. And so it doesn't try and delete it in this case. So So anyways, so the state file is by default just a terraform.state file that gets stored in your local directory. They have several state file backends. We just set ours up with S3, and we have basically one bucket for all of our Terraform work. We do vCloud and GitHub and PagerDuty, and they're all in there. And we just have them in one bucket using the files. I already talked about how it's important to run Terraform init, but I'll just reemphasize that if you aren't doing that, every new user or every time you check out of the repository, you pretty much should just do that. And another thing that this showed us early on, when we started off, we were managing a lot of our VM infrastructure with one state file. And we had to, like I said, we had to go recreate that entire thing. We've since looked at, how to separate that out so that, only this group of VMs, this application is in this state file, and this application is over here. There's several ways of doing it, but it's good to find that clean delineation. That way, if something happens, you have a lower risk of change. So somehow that's, anyways, for automation, what we did was I actually created a makefile, and the makefile basically handles making sure the init's done. It runs plan and init in appropriate places, and it makes it easy for us to, anytime we've had a user come in and start to learn it, it's really easy for them to forget, oh, I didn't run Terraform init when I did the clone. And so I try and push them like, look, just run make plan. Don't run Terraform plan, run make plan. And it'll make sure that you have everything set up properly. And then the nice thing there is if you are using Travis or Circle or Jenkins, you can just use that exact same command in there, and it's set up for them as well. Obviously, makefile is not the only way to do that. If you just want to do a regular bash script or just do the commands inside the thing, do whatever. But building out a process for testing it is a good idea. Currently, we just use make plan as our test, but it's not really adequate because it doesn't prove whether or not it's going to work. It just tells you what the change is and what is going to change. Sometimes there's a reason why when you actually run apply, it doesn't work for whatever reason, whether it's access or an error or something misconfigured on the other side. Sometimes things happen. with GitHub, we would occasionally on the internal GitHub create a separate GitHub org. That's not the greatest way, but it is effective for testing it, because then you can have a make test that runs against the test org and then runs against the production org. So that's really going to depend on your case and how deep you want to go into that rabbit hole. So a couple links. I'm going to push the GitHub-As-Code repository into the GitHub-As-Code org, and that is what the demo for this was. Then there's 2 other posts there. The Terraform docs are actually pretty good, and that HashiCorp blog post with managing GitHub is what got us started there. So along with pushing the demo for this, I'll probably go out there and push the actual modules. So if anybody's interested in looking at those, wants to work with me on improving them, pull request welcome, obviously. You can even potentially do a pull request to add yourself to the org. I haven't tried this with Travis yet, but I want to try and get that working with Travis just as kind of a proof of that way. It's a good example for people. And then as a follow through to this, I was talking to Tom, and I'm going to try and do a recording of this with the demo, so that way it's a little bit more visually cohesive for anybody that needed that. So
yeah, we'll definitely get that posted whenever we get the demo through. We do have a question for you. What would be the first step you would recommend someone do to start with Terraform? I know this is more like using Terraform for GitHub, but some of our users are brand new to Terraform and think it sounds awesome.
Basically the same thing I would tell most people about almost anything is kind of look at the tool and see if there's a use case in there that you need. Like for me, GitHub was the thing that got me started on learning Terraform. So say this example set of code that I've got will be a great walkthrough, just take through each one, each of the steps of the commit history, go back to the beginning, there's only 10 steps, and just play with them at each step and see what goes on there. That being said, the other one I've been playing with is Terraform on PagerDuty. I've done a lot of work on that one, but I haven't gotten a chance to finish it. The reason why I say that is because on that one, I'm trying to be a little bit more complicated, because we have 4 years worth of PagerDuty config that already exists, so I need to make sure it's all imported. And I want to turn around and have a tool that manages my user list in Terraform that pulls it off of our internal identity. So that way I can have an automated job that basically scrubs, whereas right now we do manual cleanup whenever we have attrition or whatever. So, but something along those lines. The other place I dabbled was basically doing a comparison. I was comparing Ansible's vCloud module versus Terraform's vCloud, and what the value add between the two was and the difference was. So that's another good case, is take something that you're already doing, and if it's got an analog in Terraform, explore it. I will straight up say that I prefer using both tools. For myself, I've separated them into use cases. I do orchestration with Ansible, but I do stateful management of my infrastructure. Like, is there a VM there, and is it running the right image, and does it have the right name inside VMware? I do that with Terraform, just like I manage GitHub with Terraform. So it's more like those kinds of resources. I could totally use Ansible to kick the VMs and make sure they're where they are and where they're available. But from a separation standpoint, I personally use Ansible more for the managing what's on the boxes. So.
That's an awesome use case. I didn't even think about using Ansible for config management and Terraform for creating the environment.
Yeah, I mean, if you're really heavy into Ansible already, then and it works to use it for the infrastructure that you're on, by all means, don't change. You know what I mean? Like, if that's a good working use case for you, cool. But if you're not even doing the Ansible side yet, and you want to start using Terraform for GitHub and PagerDuty and maybe OpenShift or OpenStack, then maybe let it manage that part and then use Ansible for managing the Linux system. So totally depends on how you work, how your systems are set up, what your workflows are. So
That's cool. I think that's the only question that's come in off of the Twitterverse. So thank you very much, Greg. And I'm sorry that GoToWebinar and Linux didn't quite jive correctly. But we'll have the recorded demo put out there. I'll get this posted too, so that everyone can watch and get your links. I'll make sure that all these resources are put into the show notes. So thank you very much. We really appreciated it. Do you have anything else, any closing remarks or anything you'd like to say?
No, thank you very much.
All right. Well, thanks for joining us for vBrownBag. We'll give you back about half an hour, and be looking for this and the recorded session soon. Bye.